Okay, let's dive right into this. Welcome to today's Explainer, where we're unpacking the kind of counterintuitive reality of AI in software development. Now, I know we've all seen the flashy headlines, right? The ones promising that large language models are going to completely automate coding and make human developers totally obsolete. But today, we're looking at the actual data from the front lines of the industry. And honestly, the truth is far more complicated and a lot more interesting than the hype. Here's the thing. AI can churn out software code in mere seconds. So, why are senior software developers suddenly finding themselves working longer hours? Yeah, it's a huge plot twist. It completely challenges all our assumptions about AI coding assistants, saving everyone tons of time. Let's move to Section 1, the AI coding boom, and see how this builds. To understand how we got here, we really have to look at the broader ecosystem. According to a major joint white paper by the Computing Community Consortium and CRA Industry, AI adoption has fundamentally shifted the entire software landscape. It's literally changing both how we program software day to day in the enterprise and, crucially, how we teach the next generation of developers in the classroom. Large language models have evolved incredibly rapidly. They aren't just simple autocomplete tools saving us a few keystrokes anymore. Not at all. They've grown into these massive engines that handle a vast array of really complex, open-ended software engineering tasks. We're talking about translating natural language directly into code, instantly generating developer documentation, automating all that tedious software testing, debugging SQL queries, and even pulling off sophisticated data science tasks by processing Python libraries, the whole shebang. Which brings us to Section 2, the hidden productivity trap. So, the breathless hype around all these new capabilities actually has a bit of a dark side. When we look past the shiny marketing, we really have to ask ourselves a core mystery. Is AI actually making software teams faster, or is it secretly slowing the whole system down? Now, what's really interesting about this is a recent study published on Archive. They analyzed developer activity right after GitHub Copilot was introduced, and they found something genuinely shocking. A 19% drop in productivity for experienced core developers. Yeah, you heard that right. No way, right? A 19% decrease in their original code productivity. So how is that even possible? Well, it really comes down to who is actually benefiting from the AI. The study contrasts two groups: peripheral, less experienced developers, and core, highly experienced developers. Now, the peripheral developers, they absolutely do experience massive speed boosts. They're generating code faster than ever before. But the core developers, they are getting severely bogged down. Why? Because they're the ones tasked with reviewing, vetting, and fixing the subpar, buggy AI-generated code produced by their junior colleagues. It's like a giant puzzle they suddenly have to fix. And that leads us to Section 3, the technical debt crisis. This exact dynamic leads directly into a severe long-term sustainability issue, because as the sheer volume of code produced by AI and junior developers just skyrockets, there's a massive corresponding rise in the rework required to actually satisfy repository standards. Basically, you're getting way more code, sure, but the quality drops right as the volume grows. And the data absolutely proves this out. Core developers are now spending 6.5% more time just reviewing code after the introduction of these AI tools, which proves that those short-term productivity gains you keep hearing about in the news, they're actually masking a growing maintenance burden that's being dumped on a shrinking pool of human experts. The CCC white paper actually has a fantastic term for this phenomenon. They call it the implicit speed limit of vetting AI code. Because human developers must meticulously check AI code for correctness, security, and readability, the vetting process itself becomes a massive bottleneck. Think about it. No matter how fast an LLM spits out thousands of lines of code, if it takes a human hours to review and test it, you haven't actually gained any real-world speed at all. All right, moving on to Section 4, trusting AI in critical systems. First off, we really have to acknowledge the stakes here. According to a 2024 Gartner report, 62% of European companies cite security and compliance as the main barrier to adopting AI in development. In highly regulated sectors like finance, healthcare, and public infrastructure, speed is no longer the priority. Trust is the priority. Because unverified AI code can hide dangerous vulnerabilities that these enterprises and, frankly, your users simply can't afford. But to break through this implicit speed limit, we are actually seeing a major breakthrough out of Europe. Research led by Professor Andrej Karpathy at HSSO Valais Wallace, working alongside the European sovereign cloud provider Xscale, is totally shifting the paradigm. They're moving away from just generating faster code and moving toward generating what they call verifiable intelligence. Their pipeline completely rethinks the AI coding process from the ground up. Step 1, the AI generates the code. Pretty standard. But step 2 is where the magic really happens, formal verification. By utilizing programming languages with incredibly strong type systems, specifically Scala, Rust, and Swift, and tools like the Stainless framework from EPFL, they can mathematically verify the AI's code behavior. If the code compiles, it is guaranteed to be safe and functional, requiring absolutely zero human intervention to manually review the logic, a real game changer. And this brilliantly illustrates how, with verifiable AI, speed and trust can finally coexist in mission-critical deployments. By automating the verification mathematically, we eliminate logic errors in financial transactions, guarantee safety for medical device software, ensure uptime for public infrastructure, and seamlessly bake in compliance for ISO and GDPR from day one. Let's head into our final section, Section 5, Teaching the Next Generation. To actually achieve this verifiable future, we obviously need the human talent to build it, right? As the authors of the CCC and CRAI joint white paper point out, computing educators are realizing they have to completely reimagine traditional introductory programming courses, the ones often referred to as CS1. We are witnessing a massive, fundamental transition here. Traditional CS1 courses focused heavily on learning syntax, writing code from scratch, and manual debugging. But in the LLM age, the necessary skills have completely flipped. Students now need to focus on reading unfamiliar code that they didn't write, decomposing massive problems into smaller chunks an AI can handle, and really mastering prompt engineering. So, the crucial point is we must overcome what researchers call the illusion of competence. See, LLMs offer a very friendly, natural language interface, which makes novice programmers feel like they're instant experts. But without a deep, foundational mental model of how LLMs actually work and how to rigorously test for correctness, these students are just blindly generating future technical debt. Which leaves us with this final, provocative thought to ponder. As AI models become faster and more deeply integrated, is the future of programming less about writing code and more about managing the machines that write it? It seems pretty clear that in an era where mathematical verification and code reading outrank sheer coding speed, the skills that make a great developer are changing forever. Thank you so much for joining me for this explainer. I highly encourage you to look deeper into these sources to see where the future of software is really heading. Catch you next time.